evening to everybody. It's a pleasure to be here to be sharing the work that I do. The purpose of the innovation that we seek when we're doing what we do is obviously to try and get a better economy in this country. And before I really talk about what we do, I'd like to give a bit of context and talk about why do we want to have economic development and innovation. What really is that all about, and how do we maximize it? Because obviously it's a good thing, and if we're able to use it to get the economy up, then that's also a very good thing. And when I'm talking about development, the question is, what really, or how do you define it? And usually when we're thinking of, for example, Vision 2030, we want to be a middle-income country by the year 2030. How do you define that? Why is it important to be a middle-income country? And clearly, it's always some economic statistics, some social indicators, numbers that we use to describe what development means and why, therefore, we want it. But really, in actual fact, it's about quality of life. It's about people and how we interact with one another. And by that measure, looking, for example, at the way that Kenyans drive in Nairobi, we're not doing very well. I think you'll agree. And that's really, in many senses, one of the signs of progress that we've got, our traffic, our roads, and so on and so forth. And what I'm trying to really challenge is, when we're talking about development, and you think about the much more simple lifestyle of some decades, centuries ago, many of the things that we seek to have in terms of quality of life were present then and are really kind of fleeting right now. So when we think about development, we think about Vision 2030. I'm challenging us to really be thinking about why are we doing it, and so it will modify the way that we go to try and do it. So it's not always about money, but it's about how we treat one another, how we want to be treated, and how we relate with God. In Africa, it's not a problem to say something like that. Most people believe in God. But of course, it's not always a given in different societies. Let me speak a little bit about innovation. And I'd like us to think about how it is that in our society right now, things are changing so rapidly. If you think about how Kenya looked about 100 years ago, it looked so different, and that's not a very long time. In terms of, there were different groups of people, and they kind of lived on their own. Like, you had the Luo community, you had the Kikuyu community, you had the Somalis community, and so on and so forth, and they weren't intermingling. And what happens, even if you look at science, when things come to change, when you have a system that's held up by certain forces, when a point comes when it's about to transform into another system that'll be held down by a different set of forces or a different arrangement of atoms. I'm a material scientist, so I'm thinking about atoms when I'm saying this. It's like a little bit like the way that we're all seated right now. There's certain order. And if we were going to change the chairs so that the pattern of the arrangement of chairs was different, right now there's some stability based on how this arrangement looks right now. But in the time when you're transforming into the next arrangement, all those forces become loose. The atomic forces become loose as it gets ready to get into the new phase or the new state, and there's a new set of stable conditions that keep that state in place. That's what we're going through right now. And so whatever we used to look at, those forces that held us together are become very weak. So there are many directions that we can move in. And those directions are influenced by what we see, what we read, whatever we get into our minds and into our hearts, from whatever sources there are for these things. So what does this got to do with innovation? Well, when you have an interface between systems, it's usually where the most exciting things happen. I'll give you the example of when Italy met Kiambu in my mother's kitchen. My mother made a lasagna made from mukimo. In Kikuyu, we have food called irio. It's a mash of peas and potatoes. And where in lasagna you have a layer of pasta, my mother put mukimo. And then you have the mincemeat stew, and then you have another layer of mukimo, and it was awesome. Seriously, I'm not saying that just because she's my mother. And it's a family secret, so I shouldn't have really told you people. I have to kill you now. No, I'm joking. But anyway, so it's when you have cultures meeting that interesting things start to happen. And it's when you have, for example, if you look at who we are as Kenyans today, almost everybody has a name that's nothing to do with our tradition, our history. And there's reasons, obviously, for that. We were colonized by people that had a certain tradition, and we took on their names. And they themselves, the British, the English, had taken on names from the Jews, mostly because of religion. So there are different influences that influence what you call yourself and how you see yourself. And my challenge is that when we think about innovation, we need to be looking at who we are, because it's when you're really kind of comfortable in where you are and have certain amount of knowledge of who you are, And then you start moving forward into what you don't know that you're able to really kind of innovate. So we should be challenging ourselves. And I think in many spheres of Kenyan life where, for example, the arts are concerned, even though I'm not an expert and I heard people speak and they said things that probably wouldn't agree with what I'm saying, but I think there's been much more innovation in music. There has been quite a lot in theater, in literature, and so on in our country, in our continent. But where technology is concerned, typically there's a certain trajectory that we follow, and it's led by the West. And there's nothing fundamentally wrong with that because, if something works, don't knock it. But there could be very interesting directions that we can move in by drawing back into who we are. And that's one of the challenges that I'd like to put. The other one has to do with who we are anatomically. So, if you think back to your biology classes, there's a certain way that your blood system, your muscle system, skeletal system, and all of that. But what you never see is any description of much about your mental system or your spiritual system, if there's any such thing. I think, again, in Africa, we have no problem believing that's there. But to scientifically describe what that is a challenge. And yet we know a lot of what we do that's most exciting comes from our spiritual nature, our souls, and so on. So I remember when I was doing my doctorate in the US, I had a colleague from Ecuador, and he had to finish really quickly. He had a family, young family. They needed to go back to Ecuador, but he was stuck. He was supposed to model some phenomena in materials mathematically, and he couldn't do it. And obviously at that point, you're on your own. You're doing a doctorate. You're supposed to be doing something that's new. And so until he did that, he wouldn't be able to graduate. So one day he comes into the lab, and he's beaming, he's glowing. And he comes on the whiteboard, and he writes down these mathematical equations. And everyone's, wow, that's beautiful. How did you come up with it? He said, last night I dreamt the whole thing. It just came in a dream. I woke up, I wrote it down, and that was it. So I always tell my class that, one of these days when we come to class, we'll sleep for 50 minutes. And then we'll share revelation in the last 10 minutes. Because it's a question of epistemology. How do you know what you know? And these are things, when we start to think outside of the box into some of these more interesting aspects of who we are anatomically, that maybe we'll get more and more innovation. So having said all that, I've really set myself up because I'm going to disappoint you. There's nothing radically different about what we do in the Fab Lab. Nevertheless, there are some interesting things. And the Fab Lab, it stands for the Fabrication Lab. It's a rapid prototyping lab. What that means in engineering speak is that you can have an idea in the morning, and in a couple of hours, you can have it actually as a physical model that you can hold in your hand. And so that's what this facility enables. And it's because there's been a paradigm shift in the complexity of certain kinds of equipment and also in their availability and the accessibility. So you have the analogy I'd like to draw that I've drawn before is that you're looking at all of us, most of us understand how to create a document, for example, or some kind of an image on a computer, and then sending it to a printer to print out. And the fact of the matter is you don't have to know how the software was written. You don't have to know how the computer works, how the transfer to the printer goes, how the printer works. You only need to know how the software works to navigate your way around this system using the software to use it, and you can use it to great effect doing that. The same thing really applies here, that we have instruments. We call them toys because there's so much fun in it. And these allow us to design something using software. We also call that computer-aided design, and send it to the machine that will make a 3D rendition of that thing. So that's a computer-aided manufacture. So examples are here. You've got on the bottom left-hand side, this machine is called a modella. It's an end mill as a class of machines, and it's like a drill bit, but it's not quite a drill bit. And what you have in the picture there is a copper plate that has some epoxy resin underneath it, and you eat away all you don't want so that you're left with traces, lines that will conduct electricity. Then you come and you solder the components into place, and you have a circuit that can make whatever it is that you have designed. The very same machine will allow you to reverse engineer, for example, a carving. So that's a carving board from, I guess, Masai Market, and it's a rhino. We're able to now do a 3D scan of that. So it's like photocopying, but 3 dimensions. You get a full rendition of that rhinoceros on the computer. Then you send it to the machine, and it'll make a copy of that for you. So again, the reason why this is very exciting, you don't have to be an engineer to use this. Just in the same way that I gave that analogy about printing, you can come in, learn how to use the software, and if you're an artist, if you're somebody who just has an innovative streak and you've been thinking, I'd love to make such and such, you should be able to come into a Fab Lab and do it. The Fab Labs are an idea from MIT. There's around 160 in the world right now. They're growing almost exponentially, kind of like Moore's law where computing is concerned. And there's a charter that governs the way that we operate. So it says that anybody should be able to come into any Fab Lab. and use it. So at University of Nairobi, it belongs to the university. The government actually of Kenya, I applied for this because I came back home from the US having done a doctorate that I couldn't apply in this country. It was kind of stuff that we don't use in this country. And so I was thinking, okay, what am I going to do with myself? And I finally, after some pretty rough time trying to settle here, because, you're coming from a system where everything is available in terms of equipment and stuff like that, but it wasn't available here. So I knew that this kind of equipment was really now quite cheap. And the government, thank God, was able to put the money, well, they were always able, but they were willing to put the money and buy a Fab Lab. The Fab Lab only costed about 8 million shillings, including shipping and clearing and everything. So there are individuals probably in this room who can buy their own Fab Lab. The farmer. And he's an IT man as well. So, so yeah, it's very exciting. And so we got the Fab Lab. Now, when you come into the Fab Lab, of course, you'd have to be able to pay for the materials you'll use, and that can be a constraint. But otherwise, and also timing and so on. But I mean, in terms of timetabling. But in essence, anybody should be able to come into a Fab Lab and use it. A feature of the Fab Lab is the Fab Academy. So what you're seeing in this is a snapshot of our video screen, TV screen, where in the left-hand corner you have a professor from MIT teaching people in about 30 labs around the world simultaneously. This happens on Wednesdays at the Fab Lab here in Nairobi. And he's teaching about fabrication. And you don't have to have a very deep knowledge of engineering to do this at all. You come in and you're taught how to navigate your way around the machines. And it's a lot of fun. It's very exciting. It's very empowering as well. This represents something of the future that I was talking to my vice chancellor about the other day and saying, look, if this trend continues, and of course it will, we're going to be out of business. Because what's happening is that you have so much information, lectures online, videos of classrooms, and many of you have seen these and have used them, from MIT, from Berkeley, and top schools in the world, videotaping the full lecture and putting it out there free of charge. IIT India, all of them do that. And what happens when I'm teaching in class, a student says, oh, but I was looking at IIT India about this Mwalimu, and they said it a bit different than you. And I'm happy because, that's the way that we grow. And so what's happening now that's extremely exciting is that courses are being offered online and you can get certification. So some of you may be aware that there's a professor at Stanford who was offering a course titled How to Program an Autonomous Vehicle. You've heard about the launch of a fully autonomous vehicle in Nevada not long ago. He's one of the principal engineers in that. The car will go on its own. You just sit there and be taken. It will stop, it will slow down, it will speed up, everything by itself, indicate kila kitu. And you just sit there and be taken. And so he's saying online, I will teach you how to do this in 6 weeks. I enrolled. I have friends in Nairobi who have enrolled. I know quite a few people who did. And the pedagogy has been, the way that it's taught has been modified to actually suit online learning. And at the end of it, you get a certificate. This guy would teach 50 people normally at Stanford University. And now when he offered this course, 130,000 people signed up. He resigned at Stanford. You don't just resign at Stanford. You don't just resign from Stanford. He resigned because this is a new thing. And so you can be in Nyahururu, you could be in Garissa. If you just have a good internet connection, you can be learning from the best in the world. So that's why I was saying to my vice chancellor, how are we going to handle this? Because this is new. And so what we're looking at is trying to help people, wherever they may be, instead of busily trying to create new curriculum, which is what we've been doing, and say, okay, we want to teach bioengineering. It's already being taught at MIT, and it's online, and so on and so forth. Just guide people through it so they're able to take advantage and get some kind of a certificate at the end of the day that can help them to get a job. Do they have to get a full degree? Of course not. And I'll give you some examples why that's true. And, it might be strange coming from a lecturer saying you don't have to have a degree, but it's true. There's too much emphasis on this thing. In Kenya especially, it's like rote learning. Let's go through this thing, let's get this certificate. I see students all the time asking me questions. Students would be asking me, Mwalimu, is it going to be in the test? Is it going to be in the exam? And I'm saying, don't worry about that. Just, do you get it? Do you understand it? That's all that's important. I've got students who have actually, for some reason, they did very poorly in the exam, but I know them. So when I write the letter of recommendation, I say this is one of the best students I've ever taught, because I know that mark doesn't mean, it doesn't define who they are. And we're too hung up in this country about marks. So back to fabrication, some of the projects. We made a 3D printer. It's not very visible, but what you're seeing in the left-hand side is a syringe, a very cheap syringe. And in a harness that allows it to fit onto the milling machine that I showed you before. In other words, the X, Y, and Z is taken care of by a machine that exists already. And what we did was we put a small motor there with a rack and pinion gear system made out of plastic on a laser cutter that we've got that pushes down and pushes the liquid out in drops exactly where you want them. It's called drop on demand. So the previous example I showed you was taking material away from the copper, for example. It's subtractive. Here you're adding material. It's additive. And an example of it is 3D printing, which is very state-of-the-art around the world. We made our own 3D printer about 2 years ago. We bought one the other day for about $1,400. Very cheap. 150,000 bob, you have your 3D printer. And the thing is that you can go online and pick what you want. Oh, I like this design. I like this item. Let me download it, print in your sitting room, and it prints, and it makes the item for you. So it's revolutionary. And in some very state-of-the-art labs around the world, they're printing by putting proteins and peptides into the syringe, or the equivalent of the syringe. They're printing human organs. Yeah, so it's wild. The Bible says that knowledge will fill the earth in the last days, let me tell you. So we were able to print this circuit over here with ours on a glass slide using a liquid that's based on silver. So that, the material after drying it and heating it and doing a couple of things, it actually conducts electricity. And make panels that we could build a toilet. We built the toilet in Kibera. It's top right hand, the blue building there. And we're looking in a collaboration with MIT, a student from MIT, at making like the building that's at the bottom. She's now actually moved from MIT. She's come to live in Kenya. And that's another exciting project. This is a wireless network that we covered Mountain View Estate for the last almost 2 years. And it's a very simple reflector. It's made out of chicken wire and plywood in the shape of a parabola. You take a normal router that you might use in your house or your office that may cost you about 8,000 shillings or something. You put it at the focal point and you beam the signal into this wire, this chicken wire. And it will reflect that signal up to 10 kilometers. Now, the original project was from MIT, and it was done in Afghanistan. Then a team came to Kenya. They teamed up with engineers from our department, students, and they then did version 2 of that. And it's actually a lot more sophisticated. And one of our engineers is shown in a picture there. His name is Tom Gone. And he did such a good job with the software. He's being hired by U.S. Army to now do the second launch of Fab in Afghanistan, based on one laptop per child. So we have talent. We certainly have talent. And now they've also formed a business. So this is very exciting. And you can see the parabolic dish there on a tower in Lavington, and it's next to the very expensive ones. And it's sending the signal from Lavington 3.5 kilometers line of sight to Kangemi, and then covering the whole of Mountain View. So these are the kinds of things that have become close. They've become very near, because of the accessibility and availability of these kinds of equipments and so on. And so we're excited. There's many things I haven't been able to show you. We've got innovators who we've given government business to, and these are guys who have nothing to do with the university. A guy who made a tea-making machine you might have seen on the news. And we got him in, and we've taught him a lot of stuff. He's doing great things. So we incubate, we innovate and we incubate, but we like to see ourselves as taking basically the supply side of innovation. So we teach people, they don't have to come already baked with their idea, and we're able then to give them opportunities. So thanks so much for your attention. Thank you.